Good morning, friends. Today we will discuss about problem on centrifugal air compressor. So write down statement of centrifugal air compressor problem. A centrifugal air compressor. A centrifugal air compressor compresses the air from 1 bar to 3 bar. A centrifugal air compressor compresses the air from 1 bar to 3 bar. Internal and outer diameter of the impeller are 0.2 meter and 0.4 meter respectively. A centrifugal air compressor compresses the air from 1 bar to 3 bar. And internal and outer diameter of the impeller are 0.2 meter and 0.4 meter respectively. Full stop. The impeller blade angle at inlet is 30 degree. The impeller blade angle at the inlet is 30 degree and exit is 40 degree. The impeller blade angle at inlet is 30 degree and exit is 40 degree. Air enter the impeller blade radially. Air enter the blade radially at the speed of 12 meter per second. Air enter the impeller blade radially at the speed of 12 meter per second. Determine speed of impeller in RPM. Determine speed of impeller in RPM. Work done per kg of air. Work done per kg of air. Thickness of the impeller blades. Thickness of the impeller blades for mass flow rate of air as 0.5 kg per second. If the impeller has 30 blades, and width of each impeller blade is 5.5 centimeter. So determine speed of impeller in RPM first. Second, work done per kg of air. Third, thickness of the impeller blade for mass flow rate of air as 0.5 kg per second. If the impeller has 30 blades, and width of each impeller blade is 5.5 centimeter. Full stop. Width of each impeller blade is 5.5 centimeter. Assume the specific volume of air is as 0.82 meter cube per kg. Specific volume is given 0.82 meter cube per kg and velocity of flow constant throughout. Assume Cp equal to 1.005 kilojoule per kg Kelvin and gamma equal to 1.4. This is our problem. Once again, I am reading this problem. Be concentrate on this problem statement. A centrifugal of air compressor compresses the air from 1 bar to 3 bar. Internal and outer diameter of the impeller are 0.2 meter and 0.4 meter respectively. The impeller blade angle at the inlet is 30 degree and exit is 40 degree. Air enter the impeller blade radially at a speed of 12 meter per second. Determine speed of the impeller in RPM. Second, work done per kg of air. Third, thickness of the impeller blades for a mass flow rate of air as 0.5 kg per second. If the impeller has 30 blades and width of each impeller blade is 5.5 cm, full stop. Assume the specific volume of the air is as 0.82 meter cube per kg and velocity of flow constant throughout. Assume Cp equal to 1.005 kJ per kg Kelvin and gamma equal to 1.4. So, according to our procedure, write down what is given in this problem. So, write down one by one what is given in this problem. So, see here, this is centrifugal air compressor problem. So, draw diagram, velocity triangle diagram. Draw here. See, we have given inner and outer diameter. So, this is center. So, here, this is CBR, CRI, CR. This angle is given 30 degree. CRO, outer velocity. CFO. This is velocity component of compressor. CWO and this is CBO. This is beta. This is phi. So, see here, this is velocity triangle for centrifugal air compressor. Now, write down what is given one by one. See here, we have given diameter di equal to 0.2 meter DO, 0.4 meter theta, 30 degree phi, 40 degree. Velocity of air at inlet Ci equal to Ci by 12 meter per second. Alpha equal to 90 degree. Mass flow rate 0.5 kg per second. And number of blades N 30. Specific volume of air 0.82 meter cube per kg. Speed of impeller. This is given in our problem. So, how to solve this problem? So, first we calculate speed of impeller N. So first we calculate speed of integer. Speed of integer. So here CPR equal to CI upon tan theta from triangle. So 12 upon tan 30 equal to 20.78 meter per second. This is CPR. So see here, from this inlet triangle we have calculated CPR, but we know CPR equal to 5 dr n by 60. So 20.78 equal to 5 into dr. Sorry, dr we know here 0.2 into n upon 60. So n equal to only n known is n. So n equal to 1984.3. So first target we have to find out speed of the integer. Now work done per kg of air. Find out work done per kg of air. G work done per kg of air. See here. First to find out tip plate velocity in CPO by the O n upon 60. So 5.4 into 0.4 into n 1984.3 upon 60. So CPO equal to 41.56. 41.56. This is our CPO. So now velocity of wheel at outlet, find out CWO. CWO equal to velocity of wheel at outlet. CWO minus CFO upon tan 40 upon tan 5. So 41.56 minus 12 upon tan 40. So 27.26 meter per second. This is CW. Now we know work done formula, work done equal to CWO into CBO. We know CWO and CBO. See, so work done equal to CWO into CBO. So 27.26 into 41.56 equal to 1132.93 Newton meter per kg. This is work done per kg. Now find out thickness of the blade. See, thickness of the blade. Thickness of the blade. Let the blade thickness to be. See here, we have considered blade thickness T. So assume here blade thickness T here. So mass flow rate equal to pi di minus nt into dr and cf upon specific volume. So see here pi we know di into 0.2 into n rt into T into dr 0.05 into 12 upon 0.82. So T equal to 0.7 meter. So see here, this is in centimeter, this is in meter. So one minute. Calculated. This is that. Mass flow rate we have given. Mass flow rate equal to 0.5 kg. So T equal to here. See, in this way we have solved this problem. So see here, we have asked first to find out speed of impeller, second find out work per kg of air, after that find out thickness of the blade. So first we have given all data, first of diagram, inlet and outlet triangle diagram for centrifugal air compressor. This is proper diagram, basic diagram, all of we know, we have learned already in previous lectures. We have given inlet outlet diameter, theta, high angle, outlet blade angle, sorry, impeller angle. Ci and Cfi, we know Ci, we have given velocity of air. So from diagram we have Ci equal to Cfi because our alpha equal to 90 because air enters radially. So alpha equal to 90 because air enters radially. So mass flow rate is equal to given 0.5 kg per second. Number of blades here we have given 30 and volume, specific volume equal to 0.82 meter cube per kg. So first you find out speed of impeller. So speed of impeller find out by CBI. For CBI we know CBI, so CBI calculate by this inlet triangle. CBI equal to Ci upon tan theta. So from this we have calculated first CBI equal to 20.78 meter per second. After that we have find out CBI, so we have find out here speed because we know formula for CPI equal to pi d I n by 60. So only unknown is n because we have calculated CPI here. So put this value in this formula and calculate n. So we are getting here n, speed of impeller 1984.3 rpm. After that we are asked work done per kg of air. So here CBO equal to pi do n by 60. From this formula we have calculated CBO equal to 41.56. Now CWO equal to CBO minus CFO upon tan phi. From this we have calculated CWO. Now we know work done formula, work done equal to CBO into CWO. Both we have already calculated CBO and CWO. After that we have find out work done per kg 1132.93 Newton meter per kg. After that we have find out thickness of the blade. Here we have assumed thickness of the blade equal to T, small t. So we know mass flow rate formula. Mass flow rate, if we have considered thickness of the impeller, then mass flow rate equal to pi d I minus mt into bi into CFI upon specific volume. Bi is the width of the impeller. So see here, put all values only unknown here T, because here we know already width of the impeller. Now put this value and find out thickness here. So in this way we have calculated all things of this problem. So any doubt, any queries, please ask me on call or on WhatsApp. Anywhere you can ask me online. Anywhere my online component we have used for asking your queries. So today we have stopped here. In next lecture we will discuss about also centrifugal problems. So today we have stopped here. Thank you.